Welcome to the first lesson of mathematics MA110, and in this video I will introduce set theory. Okay, so without further ado, let's get started. The first thing we have to define a set. So what is a set? So by definition, a set is a collection of well-defined objects, or simply a collection of distinct objects. So in that definition, we have things like well-defined and distinct elements. So these are the key phrases which are in the definition of a set: a collection of well-defined or simply distinct elements. Now, what do we mean by saying the elements in a set should be well-defined? So, by saying well-defined, the elements should be clearly defined or stated. For example, is this set a set of the first 10 positive integers, or is it a set of the first 5 prime numbers? So the elements in a set should be clearly defined. Then for distinct elements, what we actually mean by that is that the elements in a set shouldn't be repeated. So you should not repeat the elements in a set. Let's say we want to form a set that make up the letters of the word teeth. So let's say we come up with set A. Okay, so in this set A, from the word teeth, we have T first letter, then followed by E, T there. So E shouldn't be repeated in here. We have written it E, we shouldn't write it again. Then T has already been written, shouldn't be written again. We'll just write H like that. That is what we mean by saying the elements in a set should be distinct. You can't have T and another T somewhere there, E another E, H another H. No, shouldn't be like that. Then the order of elements in a set doesn't matter. We can have, let me use the same letter, set A. We can have the same set A be written as what? E, TH. So these sets, set A, set A, are just one and the same. That order doesn't matter. Okay, then you should take note that to present the set names, let's say set A, set B, set C, we use these capital letters. We use the capital letters to present set names. Then for elements in a set, we use small letters, lower case. Then you should also know that a set can also contain numbers, not just letters. Okay, so from there, let's move on to set notations. So under set notations, there are a lot of symbols that are used to represent different types of sets, and you only talk about the ones which are commonly used, or the ones you need to solve the questions. And the first one, A, is an empty set. An empty set, also called a null set. So this empty set is simply a set which does not contain any elements in it. And the symbol for an empty set, we use a pair of braces like that, or simply curly brackets like that. So that is an empty set. Then rather than that, we can also use this symbol. That is also a symbol for an empty set. So just make sure to take note of that. From there, second one, talk about a subset. Let's say we have two sets. Set A equals to elements 1, 2. Then set B having the elements 1, 2, up to 3. So if you check, all the elements of set A are also found in B. So a subset is simply a set in another set, a set found in another set, that is a subset. So how can we represent this using a symbol now? So we'll say set A is a subset, so that's a symbol for subset. It's a subset of B, meaning that all the elements of A are also found in B. We can also have some cases. Let me introduce another set, set D. So set D having elements only 1 and 2. So in this case, you can see that all the elements of set A are also found in set D. At the same time, all the elements of set D are also found in set A. We can say that these sets are subsets of each other. Therefore, to write this, you can say A is a subset of D, and at the same time D is a subset of A. So A is a subset of D and D is a subset of A. So if two sets are subsets of each other, what does that imply? That simply means A is equal to D. So it will not equal. So A equals to D. Yeah. Just ignore that. It should be A equals to D. If two sets are subsets of each other, meaning that those sets are simply equal sets. Then to summarize this statement, we can say A therefore is a subset of D and also equal to D. So this symbol there means that A is a subset of D, and D, despite being a subset of D, it is also equal to D. So these are equal sets. Okay. Let me just get rid of that so that we look at something else. So the other notation is the universal set. The universal set, represented by the symbol U or simply E. Okay, so the universal set is simply a set containing all the elements under discussion. All elements under discussion are contained in the universal set. Just know that the symbols used to represent the universal set, U or E. And from there, we can talk about what we are calling the difference of sets. Difference of sets. Difference of sets. Okay, so under set difference, we can be asked to find, let's say, A minus B. Find A minus B, or find A backward slash B, like that. So what does this mean? This simply means you are finding A intersect B complement. So immediately you see A minus B difference of sets, or A backward slash B, you change it to A intersect B complement. After that, you'll be able to solve. Otherwise, interpreting this, we can say it is A minus B is a set of all elements in A not found in B. So we can even use set builder notation, saying that A minus B actually is a set of what? So X, such that X is a member of A and X is not a member of B. So we are talking about all the elements found in A not found in B. That's what it means. So this is the set difference. For example, let me just give an illustration. Let's say this is set A, that is set B. Set A having elements A, B, C there, we have D and E. E representing universal. Okay. Then at this point, let's say we find A minus B. So finding A minus B, we should first change it to what? A intersect B complement. Then you solve. So you first list A. So A in set A what elements do we have? It's one A, B, C. So we have A, B, and C. Then in B complement simply mean all elements not found in B, so we exclude B. So getting rid of B, we are remaining with A and B. So we are remaining with A and B. That's B complement. Then what's the intersection of A and B complement? A intersect B complement equals to, so we have AB, that's the intersection. Meaning this is A minus B. So meaning this is what? A minus B, which is equal to A intersect B complement. So that's how you go about the set difference, or the difference of sets. Otherwise, this difference of sets, we can also say it is the relative complement of a set with respect to the other. So it's the relative complement of set A with respect to B. That's it. So that's the difference of sets. Then what about a complement of a set itself? How do we denote the complement of a set? So complement of a set, let's say we use set A. So to denote the complement of a set, you see A complement like that, you see that notation. Or if you don't see that, you see A complement like that, so that is to complement. Or apart from that, you see A and a bar on top, that's complement under sets. So you see a complement, or that it is still one and the same. Okay, and for a complement of a set, we can, if we say find, let's say you have been given sets, then we say find a complement. So finding a complement can also be represented as what? Find universal set minus A. So a complement is also universal set minus A. Since this one can be changed to what? Universal set intersect A complement. That notation and this simply mean one and the same. If you want to illustrate using an example, actually we can use the same example which we have. So the universal set contains all the elements, talking about both A and B. So in the universal set, let's list the elements in the universal set. E equals to, so in the universal set we have A, B, C, D, E. Everything under discussion is A, B, C, D up to E. Then what is it? Set A complement. Since we want to find A intersect, a mean universal set intersect A complement, let's also list A complement. So to list A complement, simply getting rid of A. So if you get rid of A, we are remaining with what? D and E. So we are remaining with D and E. Then what's the intersection of these two sets? What's the intersection of these two sets? So the intersection of those two sets, we check it's D and E there. That's the intersection. D, E. So D, E there, it's which set? Universal set intersect A complement. Or simply going direct, you still get D and E. So that's the notation for a complement of a set. Okay. Then let's move on to something else. So there's this theorem. Okay, let's say we have A, B, and C represent any sets. So let's say we have set A, set B, and set C. So the first thing you should know is that any set actually is a subset of the set itself. Any set, let's say set A, is a subset of the set A itself. This is also true for B. So even set B is a subset of what? Set B itself. So any set is a subset of itself. Then what does this mean? So this is what we call the reflexive property. So by saying any set is a subset of itself, that's called the reflexive property. Okay. Then B, what if we have set A being a subset of set B, and at the same time set B is a subset of set A? Actually, we've talked about this one under subset, where we say one set being a subset of the other and that other set being a subset of the first set. So this simply means that the two sets are equal. So we can say A is simply equal to B. If set A is a subset of B and B is a subset of A, to simply mean A is equal to B. And this is what we call a symmetric property. Symmetric property. So that is called symmetric. Then the last one, if we have A being a subset of B and also B being a subset of another set, let's say D, then we can actually say A is a subset of D. This is true. Let's try to demonstrate. If you have set A having the elements 1 and 2, then set B having the elements 1, 2, and 3, and set D, which has been used there, having the elements 1, 2, 3, 4, all the way up to 5. So if we check the first statement there, A is a subset of B. What does it mean? Meaning all the elements of A are also found in B. All the elements of A are found in B. 1, 2, 1, 2, like that. Then the second one, B is a subset of D. So this B is a subset of D. Meaning all elements of B are also found in D. 1, 2, 3, 1, 2, 3. Then we can actually say A is a subset of D. Since all the elements of A are found in B and D, we can summarize this that A is a subset of D. So that's what it means. Then you should know that every set has two improper subsets. Okay, so these sets can be divided into what we are calling proper and improper subsets. Proper and improper subsets. Okay, so every set has two improper subsets. The first improper subset is the set itself. Set itself. And the second one is an empty set. So the set itself and an empty set are called improper subsets of any set. For example, if you have set A having elements A, B, C. So this set A is a subset of itself. So we can say this set itself is an improper subset of set A, and the other improper subset is an empty set. Any other subsets of A, let's say if we have C equals to A, like that, D, BC, these are called proper subsets. Why are they called proper subsets? It's because all the elements of set A, let's say set A, all the elements of A, set C are also found in set A, but set C is not equal to set A. I'm repeating that. All the elements of set C are also found in set A, but C is not found in, but C is not equal to A. This will simply mean that C is a proper subset. Otherwise, if C had the elements A, B, C, then would have said C is an improper subset. Same applies to D. D has the elements B, C, or the elements of D are also found in A. Therefore, D is a proper subset of A because D is not equal to A, neither is it an empty set. Okay. Then explaining that, I'm sure I've even explained what a proper subset is. So if we exclude the set itself and an empty set, or other subsets that remain are called proper subsets. So we'll look at how to calculate the number of subsets in a given set. So before that, how do we find the number of elements in a set? Number of elements in a given set. So let's say we have set A, which is equals to ABC. That is set A. Now, how do we find the number of elements in a set? So just denote that by saying NA. So this is number of elements in set A. And in this case, you just count. We have 1, 2, 3. 3 elements. That's it. That's how you find the number of elements in a set. Then in some cases, okay, so we move on. In some cases, we can have what we are calling a set of sets. We can have a set of sets. So a set of sets is simply called a collection, class, or family. A set of sets is a collection, class, or family. For example, if you have set B equals to 1, 2, 3, 1, 2, 3. So if you check set B has other smaller sets inside it. So such kind of a set is the one we are calling a set of sets, and it's simply called a collection, a class, or a family. So set B is simply a family, a class, or a collection of sets, because inside set B we have more other smaller sets in it. That's it. Let's talk about some other concepts. The power set. Okay, so the power set of a set, let's say set A, will be denoted by P A, like that. So the power set of a set is simply a class of all subsets of set A. So it's simply a collection of all the subsets of a given set. Let's say we have been given a set A equals to A, B, and C. It's possible to list all the subsets of set A, and those subsets of set A are the ones where those subsets of set A, when listed in one set, they will be called, that one set will be called a power set. So before that, we should first know how to find the total subsets of a given set. So subsets, the total subsets of a given set will be equals to 2 to the power n. We can say 2 to the power n, a in this case, since n a representing the number of elements in that set. So in set A we have 1, 2, 3 elements. It will be 2 to the power 3. And 2 to the power 3 is simply equal to 8, meaning set A has 8 subsets. We can also list these 8 subsets. So let's try to list them. So by listing them, we are simply finding the power set of set A. So the power set of set A should contain all the subsets of A. So the first subset of this set, it's simply the set itself. So list A, B, and C. The set itself, that's a subset. Then even an empty set. Rather than that, you now start listing each of these letters one by one. So each of these letters will form a set. So letter A forming a set there, letter B forming a set, even C forming a set. So you are done with listing each single letter sets. Then you move on to a pair now. So we'll start with AB. We have listed AB, so go to AC. From AC we can move on to BC. Just to make sure I don't repeat what you have already listed, BC. Then let's confirm, do we have 8 of them? So this is 1, that is 2, 3, 4, 5, 6, 7, 8. So we have listed 8 subsets. So we have listed the 8 subsets. So out of these 8 subsets, there are 2 subsets which are called improper subsets. So what are these? It's the set itself and the empty set. These are improper subsets, meaning the remaining will be called proper subsets. Therefore, we can find the number of proper subsets. So proper subsets using a formula will be equal to, so it's 2 to the power n minus 2. So say 2 to the power n there is 3 minus 2. So this will be 8 minus 2, which is 6. So we have 6 proper subsets there. When we get rid of this entire set and an empty set, what remains will be called proper subsets. Okay, then so we said PA there representing a power set. So this is a power set now. A set which is a collection of all subsets of given set. That's called a power set. So apart from this notation for a power set, you can also have 2 to the power a like that. 2 to the power given set. That is also a notation of a power set. Okay, so from a power set we can talk about the last thing, disjoint sets. So disjoint sets, let's say we have set A equals to ABC and set B having the elements X, Y, and Z. So let's find the intersection of these two sets. A intersect B. So A intersect B, if you check A, B, C, X, Y, Z, there is nothing common there, meaning the intersection is an empty set. So from this we can come up with the definition of disjoint set. So if two sets are disjoint, it means that their intersection is an empty set. So any two sets whose intersection is an empty set, those are disjoint sets. So that's it for disjoint sets. That's what you should do. No. Okay, so in the next lesson, we'll talk about the laws of algebra of sets. For this video, that's it. I hope you have understood.